Hey guys, Mr. Enyart here with Mr. Enyart's Mathematical Compositions. This is grade 6, module 5, lesson 14. And we are going to be talking about volume in the real world. So stick around. There's lots of good calculations here. Again, feel free to use a calculator on these. It's about knowing the formulas and how to break things apart and using the rules of geometry that we've learned so far. So let's put it all together and make it happen. All right, ladies and gentlemen, this is grade 6, module 5, lesson 14, and we're going to be talking about volume in the real world. Now, since we have already been doing volume for a while and we understand that volume is the amount of cubic units that fill up the inside of a three-dimensional space, and we remember that it has a formula for rectangular prisms, being length times width times height, and a formula for square or for cubes, right? So the volume of a cube, I'll just put a little c there, is just whatever the length or the side or edge is to the third power. And then we can also do the base, right? And I'm going to use the uppercase B here because the base is what length times width gives you. And then we can do that times the height. All those give us volume. And we can use those different formulas and the knowledge we have of geometrical figures on how opposite sides, 90-degree angles, parallel sides work to find any missing information we need and then use the formulas to find volume. So in real-world situations, here is a fish tank, and a fish tank is a situation where we would need volume. So fish tanks are sold by how much water they can hold. So they're given to you by volume. Usually in gallons or something like that, but we're going to find the cubic meters, right? Because meters is our unit, and when we multiply meters times meters times meters, we will get cubic meters. And we have a situation where we have some water in it, but not all the way full. So we'll need to figure out how much water there is, and we'll need to figure out how much total it holds, and then how much more space we can fill based on what we already know. So if you want to try that, go for it, pause the video. But I'm going to go over this and one other example, and then we'll jump into the problem set. All right, so let's go through how we can solve this problem. So I've written down the key information here. In order to find how much water is the tank can hold, in general, we need to know the length, width, and height of the total tank. So our length is 3/4 meters, our width is 1/4 of a meter, and then our height is 3/5 meters. So we're just going to multiply those together. I'll do that in a second. And to show the difference between the total tank and the water that we have in it, I've written that down here on B. So the length is the same and the width is the same, but the height of the water is not the total height of the tank. And so that's just 3/8 of a meter. So we would multiply these three numbers together to find how much water there is. Then to find C, we simply take the answer we got for the volume of the total tank in A and subtract the answer of what we got for B, which is the volume of the water, and we will find the missing space. Okay, so there is a lot here. I'm going to really try and just break it down. So as you go, you can do fraction or decimal form. I even did centimeter form by transferring my meters to centimeters and then showing the formula to get my my volume down, because it would be 100 times 100 times 100 on centimeters times centimeters times centimeters, since there are 100 centimeters per meter. But when we do length times width times height for our total, we get that there are 9/80ths cubic meters of volume for the entire thing. We got 9/128 meters cubed for the volume of the water. And that makes this really hard. I found that out. 9/80ths minus 128ths, 128ths. We have to find a common denominator before we can subtract. And that's going to be a very big number. It's definitely doable. But it would look something like this. Multiplying these two give us our like denominators, and then I multiply 9 by 128 to get a 1,152, and 9 by 80 to get 720. You subtract to get 432, 10,240ths, and then you divide both of those by 16, and you get 27/640ths in simplest form, which is the answer we got doing it this way. So this way is where we just find the height of the space that's missing. Okay, this area right up here And then we just do length times width times height. So how do you find this space? Well, you have to take the total 3/5 and subtract the water 3/8, and you find the leftover height. And so to do that, I did that right over here. You can't subtract these because they're not like denominators. So I made them both 40s. By multiplying them together. It is the lowest common multiple of 5 and 8, and that would be 3 times 8, which is 24, and 3 times 5, which is 15, and then 24 minus 15 is 9, and that's 9/40. So that's the height. So now we can just do our length times our width times this height, and we will get this space, which is what I got there at the bottom. I also did it in decimal form, and you'll see that I tried to color code things for you if you wanted to pause and try and make sense of it. And the decimal form is very long, right? But that's also in centimeter form. Kind of a whole number with just one decimal might be prettier to look at, but a lot of them aren't going to be cubic centimeters. They might be cubic meters. And so, yeah, what do you think? So let's go through this one. Like when we did composite figures for area, we're going to have to cut this, right? So we're going to imagine maybe the line keeps going right here. And then we have this rectangular prism and this rectangular prism. And we're going to find the volume of each and then add them together. Okay, so this one had still a few moving parts, but a whole lot less than the previous question. So let's just take you through each one. I named this A and this B. So A's length was 12, the width was 2, and the height was the 3.14, which is the same as B. That gave me 78 meters, and I just used, instead of 3 1/4 in fraction form, I used decimal form, and it worked out evenly, so I did it that way. You could obviously do it as I did this one over here because it involved thirds. So for B, length was 9 1/2, width was 2 1/3, height was 3 1/4, just like A. And since I had thirds, I know that doesn't work out in decimals very good because remember thirds are irrational and it's like 0.333333 forever. And that could give me an inaccuracy in my decimal form. So I did it in fractional form, and then I just want to take you through my thought process in how I solved it from that point. So first, I had to change each of the numbers of the mixed numbers into an improper fraction. 2 times 9 is 18, plus 1 is 19, 3 times 2 is 6, plus 1 is 7, and 4 times 3 is 12, plus 1 is 13. So that's why 9 1/2 is 19 halves, 2 1/3 is 7 thirds, 3 1/4 is 13 fourths. So if you don't understand that, I would recommend going back to a previous video that talks about converting mixed numbers to improper fractions and vice versa, because I really break down why and how that works more than just the math that I showed right there. But that gives me, when I multiply 19 times 7 times 13, 1,729 over 24. So now I want to get it back to a mixed number. How did I get to 72 and 1/24? That's what this little bubble is here. So this is how I do that. I take my answer over my denominator and I divide them because fractions are division. And I got 72 point blah, 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 blah. Right? None of this really is important to me. The 72 is, because that means I'm able to make 72 equal groups of 24 out of 1,729. And that's going to be my whole, right? The whole amount of equal groups I can make. So then I take that whole amount, 72, and I multiply it by the equal groups I'm making, which is 24. That gave me 1,728. So now I just subtract the total number of pieces I have, 1,729, which I got from here, and the 1,728, which is the equal groups of 24, 72 equal groups of 24, and that gave me one leftover. And that one leftover is my numerator over the same denominator I've been working with. So I know that all this decimal over here, if I did 1 divided by 24, I'd get that same number. And so 72 and 1/24 meters cubed is the answer for the volume of B. So now I just combine A and B. Sorry, here we go. Right here, 78 plus 72 1/4, and 1/24, sorry. And that gives me 150 and 1/24 meters cubed for my total volume. So hopefully I was able to break down enough for you how to do these. Go ahead and try these questions on your own for the problem set, and then check back with my video, and I'll quickly go over the answers. All right, here come some answers. All right, so number one, I have that our volume is going to be base times height is our formula we're using. And since we know what the volume is, it's 21/12. That's going to be 3/4 times the base. So we're just going to divide by 3/4 to cancel that out and leave us b. And when we do 21/12 divided by 3/4, which is equivalent to 9/12, then I can just do 21 divided by 9, which is 21/9, or 2 1/3. And remember, 21/9 can also be divided by 3 to make 7/3, which is also 2 1/3. This is just a simplified version. So my final answer I will write as 2 1/3 square feet for the base. Remember, a base is in square feet because the base of a three-dimensional object is the area of the length and the width. Number 2. Same situation, but now we're just finding the height. We have the base, so 2/3 represents the base, and the height is what we're looking for, so we're going to divide by 2/3, and 10/21 divided by 2/3, written equivalently as 14/21 by times 7, is 10/14, and 10/14 is 5/7, so the height would be 5/7 feet. Now the tank, I did it the simple way in my mind. I just found the height of the missing space, right, that needs to be filled. So I took the 2 feet and I subtracted the 1/3 feet, which would be doing 6/3. 2 over 1 is 6 over 3, right? Minus 1 over 3 gives you 5/3. So we have 1 2/3 or 5/3 feet to fill as the height, and that's why I wrote that here. So my length is 5. My width is 1 2/3. My height is 5/3 from here to here. Again, I'm only looking at this space. And that's not 2, it's 2 minus 1/3. And then that gave me 125/9. And when I simplify 125/9, I get 13 8/9. So the other way you could have done it would be to find the volume of the water, since you're given 1/3 times 1 2/3 times 5, and the volume of the total, which would be 2 times 1 2/3 times 5, and then subtract the total minus the blue, and you would get that's what's left. But to me, that was a little more work. And for our composite figures, just kind of zoom in on just those. You can pause it and take a closer look, but to break it down, I just broke them here for A and B. This is the volume of A, volume of B, and then I added them to find my total volume. For here, I did this one as A and this one as B. And I got the volume of A here, the volume of B here, and then I added them and got my total volume. And for our final question, I broke it into A and B as usual, just because that's how I like to do it. You can do it however you want. And my formula is just going to be the volume of A plus the volume of B. And volume is length times width times height. So that's going to be 3 1/4 times 2 times 1. This over here was to figure out the length, which was 15/4 of this section right here. So I took 7 1/4 minus the 3 1/2, and that should give me the missing section. So 3 3/4 times 2, same width, times 1, because it gave me the height, plus the volume of B, which was the total of 7 1/4 times 2 times 1 1/4. And that was 7 1/2 plus 18 1/8. I then just changed halves to eighths so I could add them. And so 7 4/8, which is equivalent to 7 1/2, added to 18 1/8 gave me 25 5/8. So my total volume, not my television, my total volume is 25 5/8 meters cubed.